So the square root of 2 divided by the square root of 3 has to be written as the square root of 6 over 3. Oh, that's from Algebra 1. Now we'll move on to something a little more complicated. And we'll do cube roots also. Alright, so let's simplify. The square root of 2x cubed divided by the square root of 10xy. First thing I'm going to do is put these all under one square root. Back up here. So this is 2x, this is the square root of 2x cubed over 10xy. Now we'll have your y in the denominator like you wanted. Simplify this fraction. 2 over 10, that's the same thing as 1 over 5. X cubed over x is x to the 3 minus 1 is x squared. There's nothing I can do with that y. There's no kind of simplifying I can do with the y, so that's staying in the denominator. Okay. So now I separate them back out. This is the square root of x squared divided by the square root of 5y. Square root of x squared as x, and we are not worried about putting the absolute values on these because now our instructions from here on out are going to be assume all variables are greater than 0. Otherwise we would want to put the absolute value around the x. It'll come back. It's the display driver, conks out every once in a while, and it recovers. Okay. So this is x divided by the square root of 5y. Now I need to not leave the square root of 5y in the denominator. So I'm going to multiply by the square root of 5y over the square root of 5y. Yeah. Shh. Okay. So what's x times the square root of 5y? Either way, x times the square root of 5y or the square root of 5y times x. And what is the square root of 5y times the square root of 5y? Square root of 25y squared, which is 5y. The reason that I multiply it by the square root of itself again is that makes that square root sign go away. Okay? But we can also do this with cube roots. But they're just a little bit trickier. So let's take the cube root of 4 divided by the cube root of 6x. Put it all under one cube root. This is the cube root of 4 over 6x. Simplify that 4 over 6x. That's the cube root of 2 over 3x. Bless you. Yeah, I'm going back up, but when I add a new page, I always have to do that. Okay. Shh. Shh. Guys? Yes, ma'am. No synthetic division for this. It's, if you see, kind of applying the patterns, you can do just a division on the ones we're doing, like the square root of x to the 8th would be x to the 4th, 8 divided by 4. But when you've got like x to the square root of x to the 9th, when you divide 9 divided by 2 is 2.5, and you'll have, and we'll have some ways of some other ways of dealing with that, but kind of the writing out all the x's is kind of the most clear to me. All right, on to simplify. This is the cube root of 2 over the cube root of 3x. Going to use the little same trick again. I'm going to multiply by the cube root of 3x over the cube root of 3x. But that's not going to be enough. I need to do it one more time. So, because it's 3, I got to pull out, I got to get a triple. I got to get 3 times 3 times 3. If there's 4 ones, then you got to do it one more time. If it's the fourth root, you got to do it one more time. The cube root of x times x times x is x. All right. So for the numerator of my fraction, I got 2 times 3x times 3x, which is 2 times 3 times 3 is 18. Since I'm simplified, I know that one's not going to simplify anymore. And x times x is x squared. Why did I do it 3 times? Because let me show you what happens. If I just take the cube root of 3x times the cube root of 3x, that's the cube root of 3 times x times 3 times x. Oh, I don't get to pull any out of 3. I don't get to pull out an x. You got to have triples. If I do it one more time, I get another 3x here, and now I can get rid of the radical. The 3 simplifies to 3, and the x times x times x allows me to pull an x out of the radical. So I want to get totally rid of the radical. So got to multiply it one more time. Okay, you want to see another one, or are we good?